Deep within the cold telemetry streaming across our planet, a sudden geological revolution is officially unfolding. For generations, traditional space exploration viewed the red planet as a frozen, permanently dead wasteland. However, newly released subsurface radar scans from autonomous ground rovers have violently shattered this centuries-old perspective. Authentic data reveals ancient buried coastal sediment layers sculpted by the relentless energy of rushing waves and massive tides. These profound physical anomalies confirm a vibrant, dynamic, watery world hiding directly beneath the toxic rust. We finally have definite proof that water exists on Mars. And this is not what we thought the universe was. To find the definitive reality of this planetary water system, our space documentary must travel directly across the solar system to Utopia Planitia. This vast northern lowland represents the largest recognized impact basin within the entire solar system, a sprawling geographic depression spanning thousands of kilometers. This specific terrain became the historic landing zone for China's Zhurong rover during the celebrated Tianwen-1 space exploration mission. While human eyes saw only a silent wasteland of crimson dust, the advanced mechanical instruments on board the rover were preparing to unveil a staggering subsurface secret. The primary technological breakthrough of this planetary protection mission relied on the vehicle's high-frequency ground-penetrating radar. This sophisticated instrument operates by emitting high-energy electromagnetic pulses directly downward through the dry desert floor. As these radio waves encounter distinct boundaries between diverse geological materials, the signals bounce backward toward the surface receivers. This methodology allows astrophysics to map underground structures with absolute precision, scanning deep into the Martian crust from 10 meters down to a depth of 35 meters. What this revolutionary science explained next completely stunned the global research community. Deep beneath the topsoil, the radar data freed 76 distinct geological reflectors layered within the ancient bedrock. Remarkably, these buried architectural structures did not run randomly. Every single reflector sloped in the exact same direction, pointing toward the vast northern lowlands at a consistent gradient between 6 and 20 degrees. This structural alignment was observed continuously across an extensive underground terrain stretching over a distance of 1.3 kilometers. In the realm of advanced cosmology and astronomy, such a precise layout provides undeniable physical evidence of a long-lost coastal environment. This uniform layering records a classic foreshore zone, a highly dynamic tidal beach territory that existed millions of years ago. Fine-grained sediment particles, originally carried downstream by an adjacent river system, were steadily deposited along this shoreline. Over vast epochs, the relentless mechanical energy of ocean waves and changing planetary tides systematically sculpted these sloping sandbeds, which were later locked into the permanent geological record. To establish absolute authenticity, international researchers compared this precise Martian dataset directly with buried shorelines here on Earth. The underground slope angles and particle distribution profiles matched the subsurface patterns found beneath the modern Bay of Bengal with flawless accuracy. This striking Earth analog proves that the ancient alien life on this neighboring world once witnessed active coastlines, maritime winds, and powerful waves identical to our own oceans. What would you honestly feel if you saw these ancient, water-carved beaches with your own eyes? Drop your personal thoughts in the comments section below, because finding a massive prehistoric ocean completely redefines our understanding of planetary evolution. This groundbreaking astrophysics data confirms that the cold desert of today was once a thriving world of moving water. To expand our advanced space theory regarding these planetary water networks, this science documentary must shift its geographical focus thousands of kilometers away to another critical landing zone known as Jezero Crater. Within this rugged basin lies a formidable geological labyrinth called the Saita Dune Field, a vast expanse of shifting sand traps extending across the desolate valley floor. Navigating this terrain presents an extreme physical hazard for NASA's Heavy Perseverance rover, as spinning wheels in the loose soil could instantly terminate this multi-billion-dollar exploration mission. To overcome this structural barrier, Mission Control deployed a vital technological partner, the Ingenuity helicopter, marking a historic milestone in atmospheric flight. Operating at a strategic reconnaissance altitude of exactly 10 meters, this aerial scout conducted meticulous pathfinding missions to safely guide the massive ground vehicle. Moving at a highly calculated pace between dye-playing sand dunes, measuring well over 1 meter in height, the mechanical traveler picked its way forward until it finally reached a prominent rock outcrop dubbed Brack. Upon arrival, the rover deployed its heavy core drill, boring deep into the target structure to collect pristine bedrock samples at a depth of several centimeters. For years, the global cosmology and astronomy community strongly anticipated that the floor of this ancient basin would consist entirely of soft sedimentary rocks, slowly built by accumulating dust particles on a lakebed. However, the incoming spectroscopic telemetry data violently let down these long-standing scientific models. The onboard mineral spectrometers freed that the bedrock was not formed by water deposition at all. Instead, the raw instruments identified a dense igneous rock matrix dominated by a high concentration of the green volcanic mineral olivine, showcasing a structural composition virtually identical to deep volcanic landscapes located in Western Australia. This crucial astrophysical discovery forces a major reframe of our planetary history, proving that Jezero crater originally functioned as a ton cork, churning volcanic lava lake during its early evolution. This profound science explained a marvelous macro-level chronological sequence. The widespread lake system and its famous nutrient-rich delta did not exist alongside the active volcanoes. Instead, the moving water flows arrived significantly later in the timeline, flooding the deep basin only after the heavy magma foundations had cooled and solidified completely. In the specialized field of astrophysics and astrochemistry, this specific environmental merging is considered of supreme importance. Volcanic rocks containing high amounts of olivine are naturally saturated with essential chemical minerals, creating an exceptionally fertile geological bedrock. When a steady supply of stable, neutral fresh water interacted continuously with this mineral-rich substrate, it created the absolute perfect chemical environment required to capture and preserve fragile biosignatures. These unique underground settings shielded prehistoric alien life microstructures from destructive surface cosmic radiation, locking the definitive proof of a habitable planet into the permanent stone record. To fully unlock the magnificent chemical secrets of this long-lost solar system environment, our science documentary must follow a legendary explorer back to the year 2010. On Martian Sol 2449, NASA's solar-powered Opportunity rover achieved a monumental milestone. After trekking across 25 kilometers of brutal desert dust, the resilient mechanical champion finally reached the colossal rim of Endeavour Crater. This historic geological depression, measuring exactly 22 kilometers in diameter, exposed ancient structural layers. The rover focused its primary exploration activities around specialized structural features named Cape York and Spirit Point, searching for definitive evidence of past habitability. As the vehicle carefully traversed the Whitewater Lake region, its instruments identified a prominent pale-colored rock formation named Esperance. Opportunity deployed its sophisticated alpha particle X-ray spectrometer, a core tool in astrophysics, to analyze the chemical properties of this stone structure. The transmitted scientific data freed an exceptionally high ratio of aluminium and silica. In the specialized fields of astronomy and cosmology, this unique chemical signature proves that the surface was once submerged under extensive bodies of calm water. These tranquil conditions allowed hydrated mineral formations, known to geology as clays, to accumulate over vast epochs. Shortly after this discovery, the robotic traveler freed an even more striking planetary anomaly exposed on the rugged surface. The vehicle's cameras captured a thin, bright, white, linear feature cutting directly through the dark soil, formerly catalogued as the Homestake deposit. Meticulous spectroscopic scanning freed this exposed vein to be pure gypsum, a mineral compound composed of calcium sulfate. The exact science explained that ancient underground water systems had slowly dissolved calcium directly out of volcanic bedrock. This mineral-rich liquid flowed smoothly through deep underground fractures, leaving behind concentrated chemical deposits that were eventually pushed to the surface. This historic discovery presents a definitive breakthrough for modern cosmology and astrochemistry. Unlike other areas on the planet that contain highly corrosive sulfur deposits, the water that once flowed through these deep fractures possessed a perfectly neutral potential of hydrogen. This fresh water was entirely free of toxic acidity, mirroring the chemical qualities of the cleanest natural freshwater streams found on Earth. In the hunt for prehistoric alien life, a neutral water system represents the absolute holy grail, providing a safe chemical harbor where microbial organisms could easily survive, replicate, and expand. This peaceful water chemistry is also directly responsible for creating the famous planetary mystery known as the Martian blueberries. Throughout this sedimentary basin, the rover discovered countless tiny, perfectly spherical rocks embedded within the ancient sandstone layers. Laboratory analysis confirms these structures are hematite concretions, formed as mineral-saturated groundwater slowly percolated through porous stone. These unique berries possess a hard, crunchy outer shell enclosing a softer central core. This complex geometric distribution serves as a permanent physical monument to a time when water continuously shaped the Martian landscape, offering definitive proof that our neighboring world once possessed all the foundational building blocks required to spark biology. The definitive proof of extensive ancient oceans and mineral-rich volcanic lakes forces modern astrophysics to confront a deeply unsettling planetary mystery. In the specialized realms of astronomy and cosmology, this profound scientific contradiction is formally classified as the faint young sun paradox. Meticulous astrophysical tracking models demonstrate that approximately 3.5 billion years ago, our parent star burned significantly dimmer than it does today. During that early evolutionary epoch, the solar system received roughly 25% less stellar radiation and light energy compared to modern measurements. According to standardized equations of mathematical physics, this reduced energy output introduces a severe global dilemma. Without sufficient heat from the dim stellar core, the surface temperature of our neighboring planet should have plummeted far below freezing point. Standard climate simulations predict that early Mars should have existed merely as a completely frozen, lifeless ball of glacial ice and snow. Yet, the physical ground discoveries transmitted by our robotic fleet consistently present a violently conflicting geological reality. The physical scars of flowing rivers, tranquil lake basins, and extensive shorelines demand a completely different meteorological framework. This profound cosmic puzzle finally received a historical resolution through landmark datasets officially published in December 2025. Analyzing the sediment patterns captured by the Perseverance rover, international researchers uncovered remarkable new details within the Martian rock layers. The precise molecular structure of the hydrated clay mineral grains freed a dramatic, long-term environmental record. The exact science explained that these specific clay formations were not created by temporary melting events from asteroid impacts or brief volcanic outgassing. Instead, the fine-grained particles were systematically sculpted by consistent, heavy rainfall pouring down Soysar across vast regional territories. This definitive climate evidence proves that ancient Mars maintained a highly stable, long-lasting hydrologic cycle with ongoing precipitation. To support persistent liquid rain under a dim sun, the planetary atmosphere must have been incredibly dense and structurally complex. Advanced climate modeling indicates the planet was enveloped in a super-thick greenhouse gas blanket dominated by massive volumes of carbon dioxide and water vapor. This heavy atmospheric shield functioned as a powerful thermal trap, binding it efficiently to keep surface temperatures warm enough for moving liquid oceans to endure across millions of years. This incredible revelation completely reframes our entire understanding of prehistoric atmospheric evolution across the wider solar system. What would you genuinely feel if you stood beneath a massive, ancient Martian rainstorm pouring down over a red ocean? Drop your personal thoughts in the comments section below. as this chilling paradox challenges everything we thought we knew about planetary survival. The reality of consistent liquid rain on a world so far from our star proves that the mechanisms of climate and habitability are far more resilient and mysterious than traditional science ever anticipated. The reality of consistent liquid rain and ancient coastlines forces our space documentary to confront a somber planetary catastrophe. In the fields of astronomy and cosmology, understanding how a vibrant water world transformed into a frozen desert requires a precise look at planetary physics. Approximately 4 billion years ago, the internal core of Mars began to rapidly cool down. This deceleration deactivated the planet's internal dynamo, causing its global protective magnetic field to completely collapse. Without this defensive shield, the early Martian atmosphere was left completely exposed to the raw power of the solar system. Landmark quantitative telemetry transmitted by NASA's MAVEN orbiter has provided the definitive explanation for this atmospheric destruction. The data confirms that high-energy solar wind streams, stripping across the cosmic neighborhood, directly bombarded the unprotected skies. This constant stellar sandblast triggered a permanent phenomenon known as atmospheric escape, violently tearing gas molecules away from the gravity field and pushing them into deep space. As the atmospheric density plummeted, the external surface pressure dropped below the critical threshold required to sustain liquid surface water. This drastic shift forced the ancient oceans to rapidly evaporate into the vacuum. The remaining water reserves retreated deep underground, locking themselves away into permanent permafrost layers. In regions like Utopia Planitia, radar tracking has mapped immense subsurface sheets of solid ice measuring exactly 12,100 cubic kilometers, a volume roughly equal to Lake Superior on Earth. The majestic blue planet was systematically stripped of its oceans, leaving behind only a quiet, rust-colored desert world. Yet, modern astrophysics has uncovered a fascinating twist that introduces fresh intrigue into our science documentary. Meticulous orbiter observations have identified dark, narrow lines that steadily appear and grow down steep Martian crater walls during the warmest summer seasons. This recurring geological anomaly is formally classified as recurring slope lineae. Advanced orbital spectroscopic analysis confirms that these changing streaks are not caused by dry dust avalanches. Instead, they represent active seeps of liquid brine, water heavily saturated with natural chemical salts. The exact science explains that this extreme salt concentration functions as a potent antifreeze agent. This chemical property allows water to maintain an active liquid state even when surface temperatures drop well below freezing point. Dark streaks rear slowly through the dry topsoil before completely drying up during the brutal winter cycle. This discovery confirms that while the vast surface oceans are completely gone, active water transport networks continue to survive deep inside the modern Samakri Sert. Mon Moi Vital Ne proves that the dynamic geological history of Mars is still being written, keeping the possibility of modern microbial survival completely alive. This exhaustive geological investigation brings our science documentary to a heartbreaking crossroads on the Martian plains. Today, several titanium sample tubes rest silently in the dust, collected by the Perseverance rover for the historic Mars Sample Return mission. These sealed containers preserve the clearest signs of life ever discovered on the red planet. Tragically, due to severe budget cuts passed by the United States Congress in early 2026, this retrieval operation faces indefinite cancellation. The most profound cosmic clues in human history now lie completely abandoned on a toxic, wind-swept desert. These invaluable scientific treasures must wait stranded for human explorers to finally retrieve them in the late 2030s. This modern political barrier forces a profound macro-level reflection on our grand interstellar journey. For centuries, our species observed this neighboring world as a static, permanently dead wasteland. Yet, our mechanical detectives have completely let now this primitive perspective, uncovering buried coastlines, tranquil lakebeds, and active underground brine seeps. Mars does not represent a foreign, barren alien world. Instead, It functions as a beautifully preserved planetary archive, capturing a vivid geological mirror of Earth's own ancient ocean era before our tectonic cycles erased the evidence. By reading these pristine stone layers, humanity is physically uncovering its own deep evolutionary roots. This poignant reality generates a beautiful sense of cosmic hope and long-term inspiration. The temporary political obstacles of today cannot hold back the unyielding march of human curiosity. Our brilliant space exploration initiatives will inevitably cross the Tum-Toy void to reclaim those stranded samples, expanding our ultimate understanding of biology across the wider solar system. The universe isn't broken. Our map of it is just incomplete. What do you think? Does this change how you see our place in the cosmos? I'll keep exploring if there's more to uncover. Thank you so very much for watching. The universe is full of terrifying yet beautiful mysteries, and exploring them together makes this journey incredible. If you enjoyed this deep dive into the dark cosmos, please subscribe and leave a comment below. I will keep exploring. See you all next time.